Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and arguably the greatest guitar riff of all time, Smoke on the Water by Deep Purple, coming from the great album, the great CD, Days Faves, produced by the great Darby Foster. Let's get to it, shall we? We will be back, Deep Purple, at the end. We are talking more trigonometry. We are talking periodic behavior. We're going to start modeling some things with our trig function. But first, what is periodic behavior? Well, it occurs all the time in the physical world. Seasonal variations in our climate is periodic. Temperatures, daylight hours, depth of water in a harbor, phases of the moon, animal populations, and much, much more. A lot of what we're going to talk about today is just vocab, becoming familiar with what is periodic behavior, what do periodic graph looks like, what do periodic graphs look like, I should say. The repetition sometimes is called oscillatory or cyclic, depending on the situations. We'll stick with periodic. So here's an example. We got monthly maximum temperature for Cape Town, South Africa. So we got the data here, and then on a scatter plot, you can see how it's kind of following a nice little pattern here. And then if we continue for the next year and got the data, it is periodic. You can see how it starts out high, then goes low, then creeps up. And of course, that's for the changing of the seasons. Here we have the temperature in degrees Celsius. Horizontal axis, the independent variable is our months on both graphs. Here we go. A periodic function is one which repeats itself over and over in a horizontal direction in intervals of the same length. The period of a periodic function is the length of one repetition or cycle. And we will go over that very clearly in the next video. A cycloid is an example of a periodic function. Its curves traced by a point on a circle as the circle rolls across a flat surface in a straight line. So if you can imagine this point as this wheel rolls, this graph is the trace of that point. And I found something online, and we'll go ahead and show you it. You can see here's the point on the circle, and as the circle's rotating along the x-axis, it's tracing the point, and you can see how it's going to be periodic. Now it's going to go back to 0, and it's going to come back up. Oh, it's so cool, huh? But I wanted to show you an animation of that. Where are we going? Okay. And finally, we're concerned mainly with periodic phenomena which show a wave pattern. You'll see that the sine and cosine curves are waves. Okay, so a couple of vocabulary terms. The principal axis is horizontal, and it divides the function in half from top to bottom. It divides it vertically. The wave oscillates about a horizontal line called the principal axis, or mean line. We'll say principal axis. The equation of this line is a maximum plus a minimum divided by 2, which makes sense. It goes right down the middle, so it's going to be the average of the max and the min. Maximum point is going to be at the top of the crest. A minimum is going to be at the bottom. The period of a periodic function is how long for one cycle to complete, right? If you look, maybe it's better up here. If I go up, down, up, that's one cycle, and the same pattern repeats over and over and over. So the period is the distance from here along the principal axis from the start of a cycle to the finish of the cycle. So it's this horizontal distance. That is the period. The amplitude, very, very important. The amplitude of a periodic function is the distance from the principal axis to the maximum. Okay, to the maximum. You can also think of it as to the minimum because it's symmetrical. It's the same distance from here to the minimum as it is from here to the maximum. Okay, but perhaps it's simpler just to think of it as the distance from the principal axis to the maximum. It is always positive because distance is always positive. Guess what? That is it. That's all I've got for today. Like I said, a lot of vocabulary and concept. We'll talk more in class. Hope you enjoyed it. I know I did. Back to Smoke on the Water by Deep Purple so we can be out. And with that,